Thank you so much. Sorry for the delay. I'm here to present the paper. Title is so long, so I can, and Jenny already mentioned it. I only want to focus on the ETICS word. It's external thermal insulation composite system. So we work on tracking the life cycle, more or less, and we focus on specific phases of the life of these panels that are very important for refurbish the buildings, because we need to improve their thermal efficiency. As you can see, the work is, I have a lot of co-authors from different universities, because it was a research that we work on with the University of Brescia, with Stefano, Rinaldi, Michele, Melchiori, and Angelo, Luigi, Camillo, Ciribini. And then we have a colleague from the Politecnico di Milano, Cairoli, and Jens Hunhevicz from EMPA Zurich, and Daniel Hall from Delft. So, as I mentioned, we started in thinking about how to improve the quality and efficiency of the ETICS external thermal insulation composite system, because they are used for the EPBD directive, the energy efficiency directive in buildings, to improve the quality and efficiency of the envelope. And they are a system that is very diffused at national level, and in Italy, for example. But we have a lot of problem in the durability of this system, because we have a problem in the installation phase, because the companies are always trying to save cost, and not using the correct procedure or the total amount of material that they need to use. And we have this problem of detachment, as you can see in the picture, and that can have also dangerous effects on the user. So, and also as an investment, it is a very huge investment for the owners of the housing system. And so we need to try to understand how to make more durable this kind of realization and increase their quality in the realization. So not only in the installation phase, but also in the running phase, where the system needs to provide a reduced thermal losses for the envelope. And so we connected also this problem to the energy performance contract. So the idea is that we want to shift from the manual process of inspection and commissioning of the installed components, and we want to introduce an automated monitoring of this kind of system. So we thought about how to automate the controlling during the installation phase, for example, through laser scanner or computer vision activities to recognize, for example, here you can see the pattern of the entering point that we need to use for a correct installation of the system, and using the building information modeling as a support for this kind of analysis. And also an automated commissioning, because we want to check the energy performance in real time and try to understand if this kind of system are working properly, because in some cases we have infiltration of water inside the layers of the insulation system attached to the existing building, and so we have a loss of performance. If we could introduce this kind of real-time monitoring, we can have information through the life cycle and information about the energy performance in a specific moment, and we can try to support the facility managers to have information for a correct managing of the system. So the scope of our research is to tracing and make a performance evaluation of this kind of system, and with some benefits that are related to this kind of insulation components. So the emission reduction and on the building level, and recyclability of the material, the component, and we are working on the circular economy field. And then the operational efficiency through the cost reduction of heating and cooling losses and the warranty of claims, because we can improve the health and safety of the building, but also of the users, the comfort of the users and the workers and occupants. So we proposed a BIM IoT-DLT approach for this kind of system, and we used the case study for checking the viability of our approach. And we want to track, inspect, and commission the panels. And so we created a workflow to understand how to ensure the traceability and accountability of this system during the whole life cycle. Here you can see, yes, the workflow with the different phases and actors. And we are proposing like a chain of smart contracts that can track in the different phases the panel, for example, in the production phase, in the delivery phase, even for the construction site, and then during the operational life and installation. You can see the different phases in the workflow. And we have these two value proposition of this prototype. This is the transparency and immutability that we can have for these ETC panels and associated to the transaction, and the workflow automation. So we can try to also trigger this payment without an intermediary and create a trusted database for the organization of this workflow. So as a method, we started with a physical prototype. So we created a test house and the BIM model of this small building, and we created a system to monitor the thermal and hygrothermal condition of the panel, and also the possible detachment of this system. We also created an energy model for make a predictive analysis of the possible performance and thermal flows. And we defined the step of the smart contract and authorization of the information able to trigger then the blockchain payments for different phases of this prototype. Here you can see the part of the code, the smart contract that we used for checking the installation phase and the performance during the operational phase. We use this prototype. It's called UniBS prototype because it was created with the help of the Building System Institute in Brescia, and we cooperate with the university through the eLux lab, the energy laboratory as University Expo. That was a laboratory included 5 departments and working on digitization and advanced procedure for better installation and construction site improvement. And the industry, so we involved Weber Saint-Gobain for providing us with the materials that we used for creating this prototype. Here you can see the house and the first step of the scanning of the surfaces, because one of the problems that we discussed with the industry is that the companies are applying this kind of insulation system on surfaces that are not compliant with the planarity that they need to have for ensuring the durability of the system. And so we proposed different steps of evaluation of the condition of this kind of installation to promote quality. And the first step was to assess the planarity of the surface, and we can see the colors that are detecting if we have a critical planarity compared to the threshold given by the best practice manuals of Cortex. And then we created this IoT system that should follow the insulation panels during the life of the building and the installation with the low power consumption. And we wanted to avoid to have cable, 2 minutes, okay. So you can see here the sensors. And we use this different sensor, as I mentioned, for collecting information about temperature, humidity, and there was an accelerometer, so a sensor for checking the detachment. Here is a scheme of the acquisition of the data and communication system, and the monitoring of the different sensors installed in this prototype house. The prototype house had different installation and height of the sensor on the walls. And here we compared the measured value with the simulated in the energy model values. We used then the BIM model also for data visualization. So we collected the information about the temperature and related thermal flows, and we constructed this kind of visualization for checking in the different height of the prototype the temperatures. And we created like a sensor-based thermography, as you can see here into the digital model. The prototype had also 2 walls with specific critical points to detect the problem that we can face in this installation, and 2 walls with the correct procedure followed. And then we checked in the blockchain and smart contract procedure how to check the different steps in the installation phase, for example, in this case of the anchoring system, and in the running phase about the difference of temperature that can give us information about an increased thermal flow. So we want to demonstrate how to face the challenge of traceability and transparency in the supply chain scenarios, and we use this chain of the insulation panel to explain this approach. So it's a kind of exemplar implementation of this combined approach that could have, we think it could have a good impact in the industry. Thank you so much. If you have any questions.